Hello everyone, today we're going to review the measures of variability, and we have three of those that are calculated in sequence, which means we use one to calculate another, the sum of squares, variance, and standard deviations. And these three values tell us how spread the values are in the distribution. So for sum of squares, we have two different formulas, the definitional one and computational one. They are mathematically equivalent. Depending on circumstances, one might be easier to use than another. As you can see here, we use mu in a definitional formula, which means you would need to calculate the mean for the set of values before calculating the sum of squares. And in the computational formula, we don't use the mean, which means you can work with the x values directly. And also the calculations tend to be shorter, as you will see in the following example. Then we go to variance. Variance can be written as sigma squared or s squared, depending on whether it relates to the population or to a sample. Usually, as you will see, when we talk about the population, we use Greek letters, while when working with a sample, we would use Latin letters. So it's pretty easy to remember. Sigma squared, population, s squared, sample. And the formulas would be slightly different. In population, we would just divide sum of squares by n, which is the number of values. But for a sample, we would divide that by n minus degrees of freedom, which is in this case 1, because sample is an estimate. Then we go to standard deviation, that is basically calculated directly from variance. It's a square root of variance, and as you can see, it's labeled in a similar way, where for population, standard deviation would be signified by sigma, and for the sample, it would be just s. So sigma equals square root of sum of squares divided by n, and here s equals square root of sum of squares divided by n minus 1. Now let's look at the example of how we calculate the sum of squares, because this would be probably the lengthiest calculations you will do throughout your statistics class. Let's take this simple set of values. If we're gonna do that the classical way, we would need to calculate the mean first, which you probably already know how to do by now, and the mean here is 4.33. And now we draw a table with values. First, we just put x values, which is 3, 3, 4, 5, 5, 6. Then, in the second column, we would subtract the mean value from x, which you can see here. And in the following column, we will square each of those values. Remember, it doesn't matter whether the value is positive or negative, the square root will come the same, always positive. And then adding those, we get our sum of squares, which we put here. After that, we calculate our variance, sigma squared, which is, in this case, 7.33 divided by 6, which is the number of values, and we get 1.22. And just sigma, which is standard deviation, it's the same expression, but we make a square root out of it. Now, if it were not a population but a sample, we would use slightly different formulas for variance and standard deviation. Remember this and this, where we need to account for estimation using degrees of freedom. And for the computational formula, the formula itself is shorter, but it may look a little bit confusing, as these two things, sum of x squared and sum of squared x, they look basically equivalent, but mathematically they're different. And here's the difference. For sum of squared x's, we take each separate x value and square it and then add it and get a sum. And for the sum of x squared, we first add all x's together, all x values, and then square them. And as formula requires, we also divide it by n, the number of values, and we get this. And as you can see, in the end, it is the same value. It is 7.33.